Hey Math 8, I am in our new classroom making the first video here. Let me give you a shot of it. So over here we actually have some windows, and then there's Mrs. Smith's desk in the back. She's unpacking still. And there's the door, I guess. So can't wait to see you here next week. But today, I'm doing the notes for the first section of Chapter 12. I hope it goes well for you. Let's get started. So, here we go. Alright, so our goal today is to use this thing called the Pythagorean theorem. Maybe some of you have heard it before. That is the most common theorem I think there is in math. And we use it to find the missing length in a right triangle. So before we learn how to use that theorem, let's talk about a right triangle for a second. A right triangle is simply a triangle that contains exactly one right angle. All right? It's got one, it certainly can't have more than one right angle because there would not be enough degrees for that to work. A right triangle actually has parts, and I want you to know these parts. There are three sides that make up a right triangle, and we have names for them. The two sides of the triangle that make the right angle, so I'm going to draw one here. So here is a right triangle, and I'm talking about these two sides that make the right angle. They are called the legs of the triangle. So this is one leg, and this side is one leg. And then the side of the triangle opposite the right angle, that would be this side, which is always the longest, is called the hypotenuse. So this side is the hypotenuse. All right. And now that we know those parts, we are ready to talk about the Pythagorean theorem. In a right triangle, the sum, right, that means adding, of the squares, right, that means to the second power, of the legs equals the square of the hypotenuse. So it's a little confusing in words. I have written it down here in formula form. That means that if I take the length of one leg and square it, plus the length of the other leg and square it, that will equal the length of the hypotenuse squared. Now usually in math, they put letters in for these. All right? They call one leg A, and they call one leg leg B. And it does not matter which leg is leg A and which leg is leg B. And they usually call the hypotenuse side C. And so usually the Pythagorean theorem is written like this: A squared plus B squared equals C squared. All right, not a very good B. That's better. All right. So we are going to see if we can use this, and we are going to remember how to solve an equation that has squares in it, perhaps. So we're going to do two quick examples here on the front. First, we're going to find the length of the hypotenuse when it's missing. You know, the directions say find the length of the missing side. So the missing side might be the hypotenuse, or it might be one of the legs. In this first example, it is the hypotenuse. And we're going to round our answer to the nearest tenth, if needed. Maybe it will be a whole number. All right, so what I typically do is I call the missing side x, and I set up the Pythagorean theorem, right? The Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared, but I'm going to put the numbers in. So this would be 5 squared, that's one of my legs, plus 12 squared, that's my other leg, right, because here's the right angle. Now, it does not matter which order these come in, right? It doesn't matter which leg comes first. And that equals the hypotenuse squared, which is the x. So we solved equations like this in Chapter 4, though we have not taken a test on that chapter yet, so we'll see how this goes. The first thing you would want to do is you would want to simplify the squares. 5 squared is 25. 12 squared, that's 12 times 12, that's 144. And of course you can add those together. So we would keep simplifying this, and I would get 169 when I add those together. So then, how do I get rid of the exponent 2 so the x can be by itself? Well, remember, you get rid of it by doing the opposite operation. The opposite of squaring the x is taking the square root of both sides. And on my calculator, when I take the square root of 169, it turns out to be a whole number, 13. And so I have found that x equals 13, or the length of the hypotenuse is 13 inches. All right, let's do the second example, where this time I am missing one of the legs. All right, find the length of the missing side. This is the missing side. Here's the right angle. Round your answer to the nearest tenth. So again, I would set up the Pythagorean theorem. This time I'm going to use the more typical math formula, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. And I'm going to put the numbers in. So in this case, I would have x squared plus 6 squared, right? Those are my two legs. It does not matter which one comes first. I like to put the x first, but it does not matter. And that equals the hypotenuse squared, which is 12. And now I need to solve for x. So again, the first thing I'm going to do is I'm going to square these numbers. I'm going to have x squared plus 36 equals 144. Now I need to get the x by itself. So first I'm going to get rid of the 36 by subtracting 36 from both sides. And 144 minus 36 is 108. Then I need to get rid of the square. And how do we get rid of the square on the x? We take the square root of both sides. And the square root cancels out the square, so now the x is by itself. And when I take the square root of 108, I get 10.392 and some more decimals. All right. So my answer is 10.392, but it did say to round to the nearest tenth. So that would be the first number after the decimal. I want to stop at the 3, but I look at the next number to tell me what to do with the 3. Do I keep it the same or do I bump it up 1? And the 9 is telling me to bump it up 1. So x would actually equal 10.4. All right? You now know how to use the Pythagorean theorem. Let's try one application problem, and we'll be done. All right, so this is my big advice in an application problem. Make a sketch of the situation. All right, I think you should do this every time you have an application problem. It doesn't have to be a great sketch, just a sketch. Seem a little blurry here all of a sudden. Let's see. Try this. There we go. That's better. All right. You are painting the roof of a shed. The shed is, okay, so let me draw a shed. Just a simple shed there, I guess. And do I put a roof on it? I don't know, whatever. Doesn't have to be a great sketch. I'll call this the shed. The shed is 24 feet tall. So I know that this side of the shed is 24 feet tall. Let's put 24 feet there. And you have a 25-foot ladder to lean up against it. So here's my ladder. And that ladder is 25 feet tall. How far from the base of the shed can you place the bottom of the ladder? All right, so here's the base of the shed, and here's the bottom of the ladder. And I want to know this distance right here. Let me draw a line there. So what you can see there is I have a right triangle. The ladder is the hypotenuse of the right triangle. The shed makes one side, and how far the ladder is from the shed makes the other side. I'll call that x. And I can now solve this for x by doing leg squared plus leg squared equals hypotenuse squared. So x squared plus 24 squared equals 25 squared, where x is the distance from the shed to the bottom of the ladder, right? All right, so the first thing I would do is I would square my numbers. 24 squared is 576. 25 squared is 625. I now need to get the x by itself. So I'm going to get rid of the 576 by subtracting 576 from both sides. I get x squared equals 49. Then I would get rid of the square by taking the square root of both sides. And I get x equals 7. So we can put the ladder 7 feet from the bottom of the shed and still reach the top of the shed. All right, your homework is on Delta Math. Good luck. I hope that helps.